If you've ever used a breadboard, you know the primary frustration of hardware prototyping. You spend hours meticulously wiring a complex circuit, only for a slight bump to knock a critical connection loose and stall your progress. To solve the problem of impermanent hardware, we use Fritzing. It is a free, open-source software tool built to convert your temporary breadboard mockups into permanent printed circuit boards. By the end of this walkthrough, we will take a project from a completely blank workspace all the way to exporting the industry-standard files you need to manufacture your own board. Before we start, make sure Fritzing is installed and understand your basic component connections. Mastering this workflow gives you the ability to take an idea out of your personal lab and produce it as a durable, reliable piece of hardware. This interface shows the Fritzing workspace when you open a new project. Your first step is to look to the right side of the screen and locate the Component Library panel and its search bar. Using that search function, locate your specific microcontroller, an LED, and a standard resistor, and then drag each of them directly onto your virtual workspace. Once your components are placed, click and drag from the component pins to the breadboard holes to create your wiring. The goal here is to exactly replicate the layout of your physical prototype. This diagram shows what happens when you don't organize your wires, a confusing, overlapping mess. To avoid this rat's nest, right-click the wires to color-code them by function and add bend points for clear 90-degree angles. Taking the time to build a pristine virtual breadboard right now prevents you from making critical logic and tracing errors later on when the project moves into more abstract views. Step 2 is to click over to the Schematic tab. Because you mapped everything out on the breadboard, Fritzing automatically maps the logical connections for you here. However, you will notice right away that these auto-generated lines start out looking like a chaotic tangle. This schematic diagram shows how you resolve that. You must manually drag your components across the grid to untangle the dashed lines, rotating and positioning them until you have a readable layout with no overlapping lines. Organizing this view ensures you have a precise mathematical blueprint. You need this to guarantee the circuit's logic actually works before you commit to printing a physical board. Now we move to the physical design phase in the PCB tab. The dark green rectangle you see on the screen represents the exact physical dimensions of your final product. Drag your component footprints onto the screen board. You want to pack them efficiently to save space, while making sure you leave enough room to comfortably solder the parts later. At this stage, you must rigorously verify the sizing. Ensure that the digital footprints in the software precisely match the physical dimensions of the real-world parts sitting on your desk. Here, we replace physical wires with flat copper pathways called traces. Fritzing's Autoroute mathematically pathfinds routes between component pads. This careful routing dictates the board's physical size, manufacturing cost, and long-term electrical reliability. Before we export anything, we have to run a Design Rules Check, or DRC. This is an automated safety net that scans the entire board for traces that are drawn too close together or overlapping. Navigate to the routing menu at the bottom of the screen and run the DRC. Make any adjustments needed until the software confirms you have 0 errors. This file directory shows our final output. Under the Export menu, select Extended Gerber and save the resulting files into a dedicated folder on your computer. These Gerber files act as the universal language of electronics manufacturing. They form the definitive bridge between your digital design and physical fabrication. With those files saved, you can compress that folder into a zip file and upload it directly to any online PCB manufacturer's portal. After completing the design phase, the only thing left is the satisfaction of waiting until the physical, custom-made board arrives in the mail. Make sure to properly save and document your Fritzing file. You will need it to iterate on the design later, or if you decide to share your work with the open-source hardware community. Once your board is finalized, you can take your project a step further by designing and 3D printing a custom enclosure to safely house your new electronics. By completing this software workflow and ordering your own manufactured board, you move past the limitations of taping wires together. You are now developing permanent hardware.